Okay, so first, I have to cancel class on Thursday, so there won't be any class on Thursday. We'll be fine. I'm going to do 9-1, 9-2 today. We'll do 9-3, 4, and 5 next week. And that's what I was planning on covering anyway. Um, so next week will be the last week, and then we'll have review test, review final. So we're really only 3 more weeks of class left. So almost done.
Why are you canceling class for this Thursday?
Because I have something I have to do. Unfortunately, it came up over the weekend. So we're almost there. Chapter 9, as I said on last Thursday, is typically one of the toughest because of what we're going to talk about today. The hardest part isn't the math, actually. The math, we've actually done most of the math. The hardest part is understanding the problem and pulling the right information out of it, figuring out what you're actually trying to do. So we started getting to that a little bit in the last test and in chapter 8, where we were starting to make conclusions about things. So like the last question where on the test where you had to figure out, was the claim correct? Was it under 39 pounds? Or was the average lifespan of the paint correct? Those claims. And we did it very simply. We're now going to define those and actually get a very exact definition of how we actually make those claims and be able to determine those claims. First, though, we have to come up with some vocabulary, which is very important. We have 2 different types of hypotheses that we're going to look at. We're going to have the null hypothesis and the alternative hypothesis. So the null hypothesis is really what's the original mean of the problem. Okay, so whatever they give you as the mean, we're going to consider to be our null hypothesis. So we're going to put that as mean 0. All right. So in the example of the paint, the null hypothesis would have been 5 years. Okay. So whenever you see that symbol H with the little 0, that's the null hypothesis. That's going to be the mean. So those all basically, you're going to see it typically as H0 or the mean 0. And it's always going to be a single number. So we're never going to have more than one mean in these situations. Yes, there is a way to do it with 2 means and stuff like that. That's chapter 10 past. We're not getting into that in this class. So the next thing we're looking at is what's known as the alternative hypothesis. The alternate hypothesis, actually, we'll go back here first, is what we're considering. So this is what's claimed. This is what the average is. And this is what we're saying is happening or would we believe to be true. So that's going to be our alternate hypothesis. The alternate hypothesis comes in a few different flavors. So so if we're just trying to show that it is different than the null hypothesis, okay? So we're saying the null hypothesis is wrong. We're not saying lesser, greater than, we're just saying it's wrong. My alternate hypothesis is that the mean does not equal the null hypothesis. This would be a 2-tailed test. Okay, that's very important because we're looking at both sides. We're saying it's not equal to, that means it could be on either direction. Okay. So we're trying to determine if the mean is different from what they've stated it is. And as long as it's different, that's a 2-tailed test. All set? Okay. The next one we look at is we could say that we believe the mean is less than what was given. So we believe the mean is less than whatever was the null hypothesis was, or the null mean. In this case, since we're looking at the less than, it is a left-tailed test. Okay, because less than, we're going to the left side of the bell curve. So I take a guess what the third one is? More than. And it would be a right-tailed test. Exactly. So the other option is if we're saying that the mean is greater than what was originally given. And that would be a right-tailed test because we're going above it. So when we're looking at an alternate hypothesis, notice that we're not necessarily, when we're stating the hypothesis, we don't necessarily have to state a specific number. We're just stating it's bigger than it or smaller than it. Then we're going to have to actually, since we're claiming a hypothesis, think back to your science classes. You got our hypothesis. What do we have to do after that case? We have to do an experiment, right? So we have to collect some data to be able to figure out what we think, what is actually happening, and then we can determine if the test is true or not. All right? Very similar to what you did in science class. The difference is we're not going to actually physically do an experiment. We're going to look at data, which we're going to already have in these situations.
Mr. Baker, I have
Yes.
a quick question. Yep. When you were discussing about one-tailed tests and two-tailed tests in section 8.3,
Yep.
Right? In section 8.3, are the problems that we were given
Similar to this?
no, did they have to revolve around one-tailed tests or two-tailed tests?
We did a few actually. We did a couple that were two-tailed. We were looking at both sides. We were cutting it in half. And then we did a couple that were one-tailed. So yes, it's very similar to what we're talking about right now. So
Just wanted to make sure.
no problem. All right, so let's look at a couple examples. We're going to come up. What we want to do is we want to look at figuring out what the null hypothesis is, what's the alternate hypothesis, and what kind of test it is before we actually start doing the tests. Okay, so a snack food company produces 454-gram bags of pretzels. Although the net weight actually deviates slightly from 454 and varies from one bag to another, the company insists that the mean net weight of the bags is 454 grams. As part of its program, the Quality Assurance Department periodically performs a hypothesis test to determine whether the packaging machine is working correctly. It is decided whether the mean net weight of all bags is 454 grams. So, what is my null hypothesis? That my mean, or my null mean, is 454 grams. What is my alternate hypothesis? That it is not the same. So that my mean does not equal 454. Okay. Above or below, I don't care. My machine's supposed to do 454, and if it's not doing that, either direction, it's incorrect. Yes.
Are these always going to use mean, or will they eventually use different parts of the problem?
They will always use mean. Yes, there's ways to do it on other parameters, but we're not going to get into those. Those are a lot more complicated. And we're going to look at situations where we have the standard deviation and where we don't have the standard deviation doing the calculations, just like we did in chapter 8. But that'll be next week's class. All right, one-tailed or two-tailed? This is a two-tailed. Good. Okay. Good. All right, let's do another one. Don't worry, if you just walked in, all three of these problems are basically the same concept. So you'll catch it with this one. All right. So again, we want our null hypothesis and our alternate hypothesis. So it says, and this is actually similar to a problem that you guys had to do on your test. A half century ago, the average U.S. woman in her 20s was 62.6 inches tall. Suppose we want to perform a hypothesis test to decide whether today's women in their 20s are on average taller than such women were half a century ago. What is my null hypothesis? Yes, my null hypothesis is 62.6 inches tall. What is my alternate hypothesis? What do I believe is happening? Okay, so that means my mean would be greater than. Okay, so my mean would be greater than the null mean. One-tailed or two-tailed?
One tail.
One-tailed. Okay, is it right or left?
Right.
Right. Good. So the recommended adequate intake of calcium for adults is 1,000 milligrams per day. We want to perform a hypothesis test to decide whether the average adult with an income below the poverty level gets less than the recommended adequate intake of 1,000 milligrams. So what's my null hypothesis? Thousand milligrams. What's my alternate hypothesis? So my mean will be less than the null hypothesis. Okay. All right, and one-tailed or two-tailed?
One tail.
Tailed, left or right?
Left.
Left. Okay. Questions with that? Yes.
What is tailed?
Remember the bell curve? You know, the tails go off at the edge?
Yeah.
That's the tails. Which sides we're looking at. So in this case, it's less than, so we're looking at the left side of that. If the other one was right, we'd look at the right side of it. If it's two-tailed, we're going to have to look at both sides. So, and it's really going to tell us, we're really looking at, when we start doing the calculations, is what percentage that we're looking at. So is 95% above it or below it or whatever, those type of concepts that we're looking at. All right. The entire purpose of this is basically designed to figure out if, when we do the calculations, is it reasonable to assume that it's close to the mean or if it's way far away from the mean. So remember we were talking about before with certain percentages, right? Remember we were talking about it was 90%, we were 90% confident, right? Or 95% confident. Those concepts are basically the same thing here. We're going to figure out, does it fall within that our confidence level? If it doesn't, then we're going to reject it and say that, okay, then the other thing must be true. Okay? It's outside of where I think it should be. All right, so let's look at it. All right, so Mr. Jack, he's telling his girlfriend Jean that he can drive a golf ball 275 yards. So Jean doesn't believe this. So Jean asks him to do some sample hits. So hits 25 drives, and those are the results. Okay. So, step one. Let's figure out our null hypothesis and our alternate hypothesis. What is my null hypothesis for this one? Yes, my mean is 275 yards. All right. What does Jean believe to be true? She's gonna. So I could see where you could say not. That's true. However, is Jean going to be happy if it was 280? No. All right. Jean thinks it's lower than that. All right. So sometimes, like, this one isn't totally clear. Like, if you did not, that honestly would be fine in this situation. All right. But using a little psychology, Jean assumes it's less than that. Jack's exaggerating a little bit. So she's going to think it's less than that, which means it's a what? It's less than, so it's a one tail and it's left tail test, right? It's a left tail test. All right. So if Jean is correct, what should happen with those 25 hits? It should average up pretty close to that 275, right? Right. If he's accurate, his drive should average out to right around 275. If it's way less than that, he'd be wrong, right? Okay. So what would we now need to figure out to do this? Okay, so we need to figure out the mean of those hits, right? Okay.
I already have the mean in the original problem.
They gave us the mean of
275.
right. That's what he said, right?
Yes.
That's not necessarily the mean of those 25 hits. Okay. All right. So let's figure out, let's get that. Let's see if they gave it to me so I don't have to, we don't have to actually do the calculations out. Yes. His mean was 264.4. So the sample mean was 264.4. All right. And we also need to figure out the sample standard deviation, right? Okay. So the standard deviation in general is 20. So he did 25 shots, right? So how do I figure out the sample standard deviation?
Divide the population standard deviation, which was 20.
Yep.
By the square root of the sample size, which is going to be 25.
Good. So the square root of 25 is 5. So 20 divided by 5 is
4 yards.
4. Okay. So we've got that. All right. Good. Now, how, when we're looking at our confidence, when we're looking at our hypothesis testing, so we've got that information. What's the other thing that we would kind of have to figure out before we start doing calculations? Starts with a C. Yeah, we want to figure out how confident we are, right? That's the whole concept of confidence level, right? We know it's somewhere between these values, right? So we want to know how confident we are. So the bigger the number, the higher their confidence, the more confident we are, but the bigger that range was, right? That he could be in. Okay, so which confidence level do you want to do for this? 90? Okay. So we can do typically 90, 95, or 99.5 is the breakdown of it. Okay. Probably don't want 99.5 or 99. Those are really high for this. So 90, 95. Well, we can do 90. That's fine. All right. So we're going to do a 90% confidence level. For the book actually did 95, but we'll do 90. All right. So we want to find the z-score that goes along with the 95%. Or the 90%, sorry. So if we go to our z-table, and we're looking at 90%, right? Now, this is a one-tail test, correct? So we're not cutting that percentage in half. I mean, we're not looking at the outside. We're looking at 10% left over. So let's look for 90%. So 90%, we're at 1.28 is my z-score for 90%. So now we're looking less than that, right? We were looking less than, correct? So is it going to be positive 1.28 or negative 1.28? Negative 1.28. So that's my z-score. Yes.
A couple lessons ago, you had us break down the
Yep. What was 90?
1.645.
That was two tails.
Yeah.
That's why.
It would be negative 1.6.
Because no, it's going to be negative 1.28. That's the difference in it because it's the middle 90%. So there's 5% on each side. That was the two-tailed ones. So we're looking at 1.28. Okay. So let's figure out what my z-score actually is. That would be 90%. Let's look at the numbers that we got and figure out what our z-score actually is. So we got 2.264 minus 275 divided by 4. That's going to give me my z-score, correct? Oh, and I'm not back on the screen yet. There we go. So if we do that calculation, I get negative 2.65. All right. So remember I said the book did 95%. So I'm going to change these numbers real quick.
I was thinking about 95% confidence interval for a second.
Yeah, they did 95%.
Yeah,
Which is,
that's why I didn't understand the 90%
Yeah.
confidence interval and its respective z-score.
wait, hold on. That was 0.1. Okay. So this is what's known. This is what is represented by a left-tailed test. Okay, so you're going to get your bell curve, and that's why it's a left tail because we're looking at that left side. If the value that I got is in that area, we reject. If it's not in that area, we don't reject. Okay, so we did a 90% hypothesis test and determined that his average is going to be less than 275. So we reject his hypothesis. Okay. We're not saying what his average is in this situation. We just know he's lying. Okay. Or he's inaccurate. Okay. That's hypothesis testing. Any questions on that? All right. So there is this is right from the book. I can't, I won't, well, actually, we can do it this way. Hold on. We'll do this as two separate pieces. All right. So this is known as critical value testing because there's different tests that we're going to do that all work around the same thing, but this is known as a critical value test. And my critical value is basically that Z-score number that we're getting. My critical value changes based on the confidence level that I'm looking at. In this one, this example right here, this is the 95%. And that's where that negative 1.645 came from. Since it's a one-tailed, that's where that 95 comes from. We have our rejection region. If it's inside that tail, it's rejected. And our non-rejection region, if it's outside that tail. What we're rejecting or not rejecting is the null hypothesis. Okay, we're not rejecting the alternate. We're rejecting the null hypothesis. So we're saying that whatever they're saying is either correct or not necessarily correct. We're either not rejecting it or we're rejecting it. It could be true or it's probably not true. And there's the book's definitions of that. All right, so when we're looking for obtaining our critical values, we're using that Z-score formula. So it's the sample mean minus the null hypothesis divided by the standard deviation over the square root of the sample size. All right. So let's look at our critical values for one mean z-test at 5% significance level. A 5% significance level is the same thing as a 95% confidence level. Okay, same concept. So it's basically, this is the Z of the 0.05 is what we're looking at. So for a two-tailed test, we have to split that in half, right? So we're looking at the 0.25 or 2.5% or 0.025. So if we look at our z-score, now this would be the number that I gave you the other day. Was 2 point, sorry, 0.25. What was it? Yeah. Wait, that's for 99.
1.96.
That's right. I was looking, I'm like, yeah. So this will be the 1.9. So it's plus or minus 1.96. And that means we have it both sides. Okay. Now your the left-tailed and right-tailed, this is where we're looking for just the 0.05, which should be 1.645. So if we look here, 1.64, yeah, that's the 0.05. So left-tailed is going to be the what? The -1, so negative 1.645. And the right tail would be the positive of that.
How did you come up with 1.6?
It's right between, so if we look here, it's between the 4 and the 5 is what it's 0.0505 and 0.0495. It's right between those two.
Oh.
So they just split the difference and it's the 4 or 5. So if you did 1.64 or 1.65, either one of those would have been fine. The more accurate term that they typically use is the one for 1.645. Now, here's the nice thing. Do those ever change? Did we use a problem to get those numbers? No. Those are your actual numbers for a 95% or 0.5 or 5% significance level. Those three numbers will never change. Okay, so if you write that down, it's okay, if I'm looking at a 5% significance level two-tailed test, my z-score is plus or minus 1.96. Period. Like I don't have to go through and find it again. I've got it. Or if we're doing a one-tailed test, depending which side, it's 1.645. Okay, so those numbers won't change. All right, so if we're doing a critical value approach to hypothesis testing, here is the steps. So we state the null hypothesis and the alternate hypothesis. We decide on our significance level. So when we did it, we chose, in essence, it was called, would be considered 10%, because that's my significance level. We computed the value of the test statistic, which we did was the z-score. We determined the critical values. We looked at the z-score there. And then we found the value, if it fell in with it or not. Okay. All right. Since I finished that quickly, I'm actually going to go on. All right.
In the book, I see the word test statistic mentioned?
Yeah.
What is that?
That's your, in this case, 1.28, the one we just did. The test statistic is that z-score that we're looking for. Yeah. All right, so we're back to Zach. And we figured out that his, when we did our alpha calculation, right, we ended up getting his z-score was negative 2.64, right? If I remember right. Oh, it's 2.65. 2.65. That was the z-score of where his ball fell, or where his average fell. Okay. All right. So we just covered what was known as the critical value test of how we can do it. We're basically looking at comparing two z-scores. We can do it another way, which is known as the p-value test. Notice I didn't write down all the other stuff because we still have to do all that stuff. We still have to find our null hypothesis. We still have to find our alternate hypothesis. We still had to find the mean, standard deviation. We still had to do all those calculations. None of that actually changed. The only thing that does change is how we determine if it failed or not. Okay. In this case, we're going to look for 5% significance because I want to do 5% this time. I think I totally spelled significance wrong, but that's okay. So we're looking for 5% significance. When we're determining this, what we're going to look at is we find the z-score. Notice I didn't find my critical value. I didn't go look and said, okay, I want the 5 or the 10%, the 5%, look at my z-score, find that z-score. We didn't do that. We just got our z-score for our information. We're now going to look at the z-table for the negative 2.65. So if we look at negative 2.65, I get 0.0040. Right? So my percent is 0.0040, which is 0.4%. When we're looking at the p-test, what we're doing is we're actually looking at, is the percent that I got less than the significance level that I want? So since I want 5% and we're at 0.4%, we reject. Because 5% is greater than 0.4%. Or 0.4% is less than 0.5%. So the score that I got is less than the significance level. So therefore, we reject. Notice, not much different. It's just using a different number to compare. Okay. Yep. So we have our. All right, I wasn't sure how long it was going to take me to get through the other stuff. So your p-value is what your significance level is. So if we're looking at 5%, so 5%, that means there's 5% there, there's 5% there, and in the two-tailed test, It's 2.5% on each side. Okay. So that's the difference when we're looking at the one-tailed or the two-tailed. That's where's the percentage is broken down into. And the two-tailed is just split evenly between the two. All right. Let's look at a couple. You'll notice that most of these examples, except for the very first one we did, are just simple problems because we'll get into the more complicated ones. We do 9.4 and 9.5, and we actually have to figure out have the standard deviation and all that other stuff. So these are just the tests that we're using to do it. All right, so the value of the test statistic for a left-handed one means z-test is z equals negative 1.19. So that's my test statistic. That's the z-score that we got. We have to determine our p-value. So think about it. What does p stand for? Percent. That's literally it. All right, so we're going to go to our z-table, and we're going to look for negative 1.19. 1.19 is 1170. So 0.1170. So at the 5% significance level, are we rejecting or not rejecting the null hypothesis? We're not rejecting. Because 1 is greater than 0.05. And we will want it to be less than to reject. All right, so we've got our test statistic is z is 2.85. So find my p-value and determine if I'm rejecting or not rejecting this. All right, so what's the p-value? Okay. Is that the number I want? What do I want? Because remember, the whole, hold on, let me pull up the, go back real quick. So we're looking at a right tail, right? So we're looking at this percent right over here, correct? So that's not 99.78%. That's from here over, correct? So what's the value that's actually over in here? We have to do what? Yeah, 1 minus it. Now, your other option would be, just look at the negative side. So you get 0.0022. That was the, absolutely nobody got that question correct on the test. The heights of the women question. Pretty much everybody had that. And since we were looking at greater than it, you had to subtract it from 1. So just remember, if you're looking at your Z table, if we want greater than on that side, or actually since I'm looking at you this way, we would look at, you could look at the negative version of it, and it will always give you that little piece that's on the side. That saves you a step of subtracting 1. Okay? Because it's going to be the same, remember, it's symmetric. It's the same on both sides. So if the little piece over here has to be the same as the little piece over here. So, or you can just do 1 minus it. Just think about what the number makes sense. In this case, when we're looking at it, does 99.78 or make sense for the problem of how we're doing it? No. So we got this. So are we rejecting or not rejecting the null hypothesis if I want a 1% significance level? We're rejecting because 0.0022 is less than 0.1. So we reject. All right. Let's do this one. All right, so what's my p-value?
0.0436.
Okay. So at the 5% significant level, are we rejecting or not rejecting? Why?
That's gonna give you 4.36%.
Okay. We can't reject this one.
Because it's 210.
Yes. Now, you can look at this as one of 2 ways when you're looking at a 2-tailed test. The book just doubled the 4.36 and did it that way. I do it the other way. I cut the significance level in half because we're looking at 2.5% on each side. Okay, so since the negative 1.71 is on the left side, doesn't matter which way we're going, there's only 2.5% on each side. So in this case, the 0.0436 is greater than the 0.025, which is what we're looking at. So we cannot reject. Okay. Just remember, your two-tailed, you cut the significance level in half. I think that makes more sense than saying you double whatever you got. Either way will come out to be the exact same response and answer. But if you have two tails, you cut whatever your significance level in half because you have half on each side. All right. So I've given you your approach for the critical value, and here's the p-value approach. So we state the null hypothesis and alternate hypothesis. We decide the significance level. We compute the value of the test statistic. We determine the p, and then we determine which direction it goes. I want this. It's next to it. So I'll show you something. Nope, not that one. Why did it not? Try this again. So this is P. Let's shrink this a little bit. And this is the critical value approach. State the null hypothesis, decide the significance level, compute the statistic. The only difference is step 4. Okay? Determine the p-value or determine the critical values. Okay? Both of them go back to the z-score, the z-table. One, you're using the test statistic. One, you're using the significance level. That's basically the only difference between the two. Okay. And then you compare it based on what you got. So in essence, they're basically identical. Okay. And the concept and all the stuff you have to do for it. It just depends on at the end when you make your statement, how are you saying that it's rejected or not rejected? Okay. And in all honesty, it's a personal preference on which one you choose to do. There's not much difference in the concept of it. It really depends on, do you like the critical values or do you like the percentage values, the p-value? So. All right. Any questions on those? Okay. 2 things. Just remember, there is no class Thursday. So for those of you who just came late, there's no class Thursday. And if you also came late, I have your test scores. So come get your tests.